Okay, welcome back to EC Concept. So this is the lecture series on short note. Okay, today we are going to discuss about short note on steel structures. In that, design of tension member. So already we having seen plastic analysis as well as connections, right? So now we are going to discuss about the design of tension member. Okay, here the first we will see some of the concept. So that is enough for your examination perspective. Okay. In the tension member, generally subjected to first of all is a shear lag. Okay, what is a shear lag? Suppose, for example, there was a member. If this member is subjected to axial force, that is PP, then at any section the strain is uniform because of the force is axial. If the strain is uniform, then there is no shear lag will come. At the same time, there was a force. The force somewhere here acting, another force is acting somewhere here P. So because of this eccentrical loading, this eccentricity, there was a non-uniform strain will takes place on every cross section. Okay, on every cross section. Because of this non-uniform strain, the shear lag effect has come. Okay, so the shear lag effect is a effect which is due to non-uniform distribution of the strain. Okay, meaning if the centroid of the section coincides with the forces, that is axial force, then there is no strain. There is no non-uniform strain. If the centroid of the section and the axial force both are not coincides to each other, then there was a strain. Then there was a shear lag effect will come. Okay. See, we are going to see this now. Okay. Shear lag effect is non-uniform straining of a member due to tension. Shear lag reduces the efficiency of tension member that is not directly connected to the gusset plate. Okay, so because of the shear lag, the efficiency of the tension member is reduces. Okay, now shear lag effect, yeah, shear lag effect exists at the connection level only. This point is important. Okay, shear lag effect generally exists at the connection level. Now, second concept, lug angle. So actually this lug angle is used to reduce the shear lag effect. Okay, that's the thing. See, lug angle is a small piece of angle used to connect outstand leg of tension member to the gusset plate. Okay, for example, see, what is a lug angle? So there was a gusset plate. Okay, there was a gusset plate. In that, okay, so what is main angle? This is main angle. And another one is lug angle. Okay, another one is lug angle. This is the lug angle. Okay, it's a small angle. A small angle. Okay, and this is the lug angle. Okay, and this is the main angle. This is the main angle. Okay, so this main angle, if you are not using the lug angle, then the main angle is subjected to non-uniform strain. Because of non-uniform strain, there was a shear lag effect. So that's why, in order to make the uniform strain, we are adding a small angle. That small angle is called as lug angle in order to avoid the non-uniform strain. Once we avoid non-uniform strain, then there is no shear lag effect. Okay. Now, see, this is the connected leg. This is connected with a gusset plate with a bolt. This is the lug angle, connected leg. This is connected with a gusset plate. Now, these two are outstanding leg, main angle. So, we can use this by bolt. We can connect this outstanding leg. Okay. So, this is the bolt group 1. We can take it. This is the bolt group 1. Bolt 1. And this one is bolt number 2. That is, this is bolt group number 2. And this one is bolt number 3. This one is bolt number 3. Okay, we will see what is what now. The purpose of lug angle is to reduce shear lag effect and to reduce the length of connection to the gusset plate. So the purpose of lug angle is reduce the shear lag effect and to reduce the length of the connection to the gusset plate. For this purpose only we are using the lug angle. Next one is lug angle is used then if you use the lug angle, then the resultant reaction and action passes through the CG of the main angle. So once it is passes through the CG of the main angle, then there is no non-uniform strain. See, since the resultant action and reaction pass through CG of main angle, stress versus strain is uniform, hence no shear lag. Both connecting outstanding leg of main angle and lug angle, that means this one. Okay, that means this one. Outstanding leg of main angle and outstanding leg of lug angle. These two are must started. The first thing is you have to connect these two outstanding leg. You have to connect these two outstanding leg started in advance of all other bolt to ensure that outstanding leg of main angle transfer to the load on the lug angle effectively. This bolt started to share the load in advance in order to transfer the load from main angle to the lug angle. So actually the force is acting on the main angle, right? So this force is transferred to the lug angle through this bolt, through this outstanding leg connector bolt. Okay. And at least we have to use minimum 2 bolt on the outstanding leg. This is the question. Okay. Minimum 2 bolt you have to use at section 2. That is bolt group number 2. Next one is minimum number of bolt at location 3. Location 3 means here on the lug angle, you have to use 2. So here also 2, outstanding leg connection 2, and lug angle, there also you have to use 2. Okay. Next one is if lug angle is not used. Suppose if you are not using lug angle, then outstanding leg is affected by shear lag. This outstanding leg is affected by this outstanding main angle outstanding leg is affected by shear lag. As per IS 456, IS 800 2007, 2007, shear lag factor beta is take care of loss of efficiency due to shear lag should not be less than 0.7. Okay. IS 800 2000 says if you are not using lug angle, then you have to reduce the area of cross section. Okay, because the efficiency reduces. So that by considering the shear lag effect, you have to consider the beta shear lag factor. Beta is equal to 0.7. Why we are considering? To take care of loss of efficiency. Okay. So this is all about leg angle. Now we are going to see about the long joint. Third concept is a long joint. See, the long joint concept is, suppose this is the member and this is the another member. Okay, and this is the load P. We are having a bolt. Okay, okay, and this distance, yes, this is the length of joint LJ. LJ greater than 15 times the D if it is. Okay, greater than 15 times the D, where D is the dia of bolt. Where D is the dia of bolt. This is the bolted joint. At the same time, suppose if it is a welded joint, suppose if it is a welded joint, if it is a welded joint, then you know for a welded joint, this is the weld length of weld. So this is LJ greater than 150 times the throat thickness. That TT is equal to throat thickness. TT is throat thickness. Okay, this also long joint. If the for bolted connection length of joint is greater than 15 times the D, or LJ is equal to greater than 150 TT for a welded connection, then you have to, that is the connection efficiency will be reduced. Therefore, you have to consider the reduction factor in order to take care of the reduction in strength due to the long joint. Okay, so here some of the point we are going to see. You know, it is assumed, it is assumed that applied load, applied load is shared by all bolts equally. That is assumption. It is assumed that the applied load is shared by all bolts equally, but when the applied load, but when the applied load is within proportionality limit, within proportionality limit, outer bolts take more load than inner bolt. That means, but assumption is all bolts are takes load equally, but within elastic limit or proportional limit, outer bolts takes more load than the inner bolt. Okay, this assumption bolt. Now this assumption that all the bolt share the load, all the bolts share the load equally is valid, equally is valid at collapse, at a collapse load only, at a collapse load or failure load. Collapse load or failure load only. You know, the assumption which is holds, that means all bolts share the bolt share load equally. That assumption is only holds good when the member uh, reaches to the collapse load or failure load. But if the member reaches to the elastic limit or proportional limit, then the bolt are not equally shared all loads. So this is a very, very important assumption. Okay, important point. So next one is at a collapse load, at a collapse load condition, at a collapse load condition, all bolts, all bolts yield and share the load equally. All bolts yield and share the load equally. Okay, that you know. Now, next point, give the length of the joint, if the length of the joint is more than 15 times the D or 150 times the throat thickness, then it is called, then it is called long joint. Then it is called long joint. So if the length of the joint is more than 15 times the D or 150 TT, then it is called long joint. Okay. In long joint, in long joint, end bolts take more load, more load than inner bolt, than inner bolt, so that failure of the bolt, failure of the bolts in long joint, in long joint is sequential. In long joint is sequential. Means starting with the outer bolt, starting with outer bolts and progressing and progressing towards the center, progressing towards the center. This type of failure, this type of failure is called unbutton, unbuttoning. This type of failure is called unbuttoning. Okay. So unbuttoning is a tension failure in long joint. Unbuttoning means unbuttoning is tension failure in long joint. In long joint. See, if the length of the connection is more than 15 times the D or 150 times the TT, then there was a failure. Okay, that means outer bolt take more load than the inner bolt. Because the outer bolt is take more load, the outer bolt gets failed first, and progressively the failure is happen towards inward. This kind of failure is called unbuttoning failure. Okay, that is about this. Okay, long joint. Next one is, next important point, third, fourth one, grip length. About grip length. Grip length, that is LG. Grip length, that is LG. So grip length means this. See, there was a okay. This is the bar. This is P, and this is P. Okay. Okay. Now this is the eccentricity, right, between the two load. And this one is the grip length, LG. This is the grip length. Okay. If the grip length is greater than 5 times the diameter of the hole, okay, so we can write here the important points. If the grip length, if the grip length is increases, then efficiency, of joint decreases due to bending, stresses developed in the joint. Due to bending stresses develop in the bolt or joint. Okay, bolt. Okay, to reduce the effect of bending stress in the bolts, IS 800 says that LG should not greater than 5D. See, what is the meaning? If the grip length is more, then unnecessarily this bolt is subjected to bending stress. So why bending stress? This eccentricity increases. This eccentricity create a moment about this bolt. Therefore, the bolt gets bending. So IS 800 says you don't take or allow the grip length is more than 5 times the D. Okay, and continuation of that grip length, that is, if 5D less than LG less than 8D, now 8D, then factor to take care the bending additional bending stresses in the bolt. Okay, a reduction factor you have to multiply to care of additional bending stress. Okay, because here we allowed up to 8 times the diameter, right? Now next point, if LG is greater than 8 times the D, then the section has to be redesigned. Then the section has to be redesigned. Okay, meaning that is increase the diameter of bolt. Increase the diameter of bolt. Meaning they said LG should not greater than, okay, LG should not greater than 8D. That is a final value. Okay. Now this is all about grip length. Now fifth one is slenderness ratio. Slenderness ratio. So that is important. That is lambda. Lambda is equal to L effective by R minimum. Right? L effective by R minimum. Now we are going to see one by one. What is the slenderness ratio? Okay. So the first one is for pure tension member. For pure tension member, lambda is equal to 400. Next one. For pure tension member, okay? This one for pure tension member. Now, for pure tension member subjected to reversal of load, subjected to reversal of load due to wind and earthquake. Due to wind and earthquake. Due to wind and earthquake is equal to 350. Next one is for pure tension member subjected to reversal of load due to live load only. Due to live load only, which is equal to 180. Now, for a hanger bar used in suspension cable, suspension bridges, lambda which is equal to 160. So these four values you have to keep in your mind. So here is a lambda, here also lambda. Understood? So these are the four values. So this is all about the slenderness ratio. Okay. Now, next we are going to see that is a load calculation. Okay. Now load carrying capacity, fifth one. This is the last one, sixth one. Load carrying capacity of tension member. Load carrying capacity of a tension member that we are going to see. First of all, PT, which is equal to AG into Fy divided by 1.1, or PT, which is equal to A net into 0.9 Fu divided by 1.25. This is based on cross section yielding. Based on cross section yielding. Okay. And this one is based on rupture yielding. So this is based on rupture yielding, and this is based on the cross section, gross cross section. That is a meaning. Gross, that is a total cross section yielding. Now here the challenge is how to calculation of A net. Okay, this A net calculation. So I'm using A net calculation. So they will ask you the question for A net. So first one, A, chain bolting or riveting. For chain bolting, so this is the bolt arrangement. Okay. For this chain bolting, the P, and there is a P. Okay. At any section, okay, this is okay XX, XX. Now XX A net at the XX section is equal to A net at the section XX is equal to B minus number of bolt at the section 1 section XX into diameter of bolt hole, right, into thickness. This is the way to calculate the A net. B for A net calculation for a staggered bolting. This is the chain bolting. Then for a staggered bolting. For staggered bolting. You know, for the staggered bolting, okay, for staggered bolting, one, two, three, four, like that. From here to here, this is the staggered gauge length. Okay, sorry, staggered pitch, not a gauge. P1. From here to here, this is staggered gauge length, G1. Similarly, this one is G2 and this is G3. But a P1, P2, P3, this is P1, between these two P2, P3, P4. Okay, anyhow, the distance between two bolt is P1, P2, P3, etc. Okay, so this is the staggered arrangement. Here A net is calculated. A net is equal to total B minus N1, that is a number of bolt hole in the section, N1 in the diameter of hole, plus P1 square divided by 4G1 plus P2 square divided by 4G2 plus etc. into thickness. Okay. Now N1 means the section that you are taking, number of bolt hole in the section that you are taking. Okay. Now C, next one is C, that is single angle connection. Okay, single angle connection. So this is the gusseted plate. In that, this is the angle, single angle connected to the gusset plate. So area of, this is the connected leg, this is area 1, area of connected leg, and A2 is equal to area of outstanding leg. So here A net is written as A1 plus K into A2. Now what is a K? K is equal to 3A1 divided by 3A1 plus A2. So this is the formula that you have to keep in your mind. Very, very important. Directly they will ask you the formula for a examination. So this is one. Now, next one is if two angles are connected back to back on the same side of gusset plate. This is one angle and this is another angle. This is another angle which is connected in the gusset plate on the same side of a gusset plate. Same side of a gusset plate. This is the gusset plate. This is the gusset plate. Okay. Same side of gusset plate. This is connector, same side of gusset plate. Okay. That same side of gusset plate, two angles are connected back to back. Like that, we can. Two angles are connected back to back on the same side of gusset plate. On the same side of gusset plate. Then A net is equal to K1 plus K into A2. K is equal to 5A1 divided by 5A1 plus A2. Okay. Next one is two angles are connected back to back. Two angles are connected back to back. But in between that, there was a gusset plate. In between that, there was a gusset plate. Two angles are connected back to back. Two angles are connected back to back. Back to back. In between that, there was a gusset plate. Here, this is the gusset plate. Be careful. The difference between these two. And here, A net is equal to A K A2. Here, K is equal to 3A1 plus A2. So this is the formula. K formula. Here all are A1 is equal to area of connected leg. A2 which is equal to area of outstanding leg. Okay. So these are the important points that you have to keep in your mind. Okay.